Welcome to the Introduction to the Brain Visualizer tutorial. The Brain Visualizer allows you to visualize brain structures in 3D and view neuronal activities within them, as well as create new brain structures and modify their properties, and create cortical mappings to rewrite the brain. The Brain Visualizer consists of two major workspaces, the 3D Brain Monitor and the Circuit Builder. In both of these environments, you will have access to tools enabling you to add or remove cortical areas, modify cortical properties, or create connectivity rules and modify them. You can immerse yourself in the 3D monitor or circuit builder environment, or you could select one of the split view options to have visibility to do both. We recommend you to operate in the split view mode to leverage the best of both environments. The Brain Visualizer provides the means to adjust the sizing of user interface elements. You can also gain more insights about your artificial brain by expanding the health bar, which provides information about the size of the brain and its health. Let's dive into the details. The top left navigation bar below the Neurorobotics Studio options allows you to add cortical areas, create connectivity rules, change the font, switch between the 3D monitor and circuit builder views, or monitor brain health. To add a cortical area, select a cortical area type, then select an input type, edit the cortical area details, and refer to the input and output cortical area tutorials for more details. To add a connectivity rule, select a connectivity rule type, edit the connectivity rule details, define its vectors, and you can refer to the connectivity rules tutorial for more details. To adjust the font size, click the larger A to make the font size bigger, or click the smaller A to make the font size smaller. Neurorobotics Studio allows you to choose between 4 different views. First, we have the vertical split of the Brain Visualizer, otherwise known as BV, and the Circuit Builder, otherwise known as CB. Then we have a horizontal split between the BV and CB. We have just plain BV and just plain CB. To monitor your experiment's health, you can edit how fast the brain processes information in hertz, which is equivalent to the number of refreshes in a second. You can also view the number of neurons and synapses actively in your experiment, and you can monitor the health of your experiment with those 5 bars. To edit one of your cortical areas, click it in either the BV or CB and select the magnifying glass. A toolbar should pop up with the option to view cortical area details of its details, such as the neuron firing parameters, postsynaptic potential parameters, connections, and danger zone. There will be a dedicated tutorial explaining all properties in detail. Connect a cortical area by selecting its source, destination, and connectivity rule. You can copy a cortical area as well as delete one. The Circuit Builder enables you to view the wiring diagram of the brain, where you can interactively modify the wiring. You are able to visualize mapping webs between cortical structures and modify connections via dragging and dropping lines from the output to the input and vice versa. You cannot connect input to input terminals or output to output. Input terminal connections appear on the right, and as you can see, output terminal connections appear on the left. Once the Edit Mapping box shows up, you can edit its details, such as if it's inhibitory versus excitatory behavior and plastic versus non-plastic properties. Non-plastic connections will appear as white circles, while plastic will be yellow. As you can see in this example, your circuit can become very intricate. The 3D monitor view allows you to visualize the neurons firing in your custom brain. The blue boxes represent cortical areas that turn red when activated. You can manually activate the neuron by holding Shift and clicking that specific box, turning it green. The layout of your cortical areas make up the 3-dimensional cortical structure of your custom brain. As you can see by the X, Y, and Z axes in the brain, your cortical areas can range into different heights and lengths. This axis also serves to monitor if the brain's connectivity is on or off.